Welcome to reInvent 2024. Imagine a world where government services are as intuitive and responsive as your favorite smartphone application. A world where citizens can get access to instant and accurate answers to their most complex questions, 24/7, without ever having to wait on hold, and without having to go through a labyrinth of web pages. The good news is that there are forward-looking public sector agencies that are using technology to deliver superior customer experience and optimizing service delivery. Let me tell you a quick story. The US Department of State recently faced a monumental challenge: how to make sense of their massive catalog, service catalog, of the Foreign Affairs Manual and its associated handbooks. Now, the latter is a comprehensive, authoritative source of State Department organization, procedures, and policies. It is over 20 volumes, 10,000 plus pages. It's a digital maze that had staffers and citizens frustrated alike. Enter generative AI. Within a short period of time, this vast sea of information was changed into or transformed into an intelligent and conversational interface that could answer the most complex questions in a matter of seconds. The results? Better customer experience, cost savings, improved delivery. Now, this is just one example of the practical applications of Gen AI in the public sector. Today, we will pull back the curtain on this technology, and we will show you how it works. But most importantly, we will demonstrate to you how you can use similar technology to improve your operations. I'm Mickey Iqbal with AWS, and along with my colleagues, Naresh Dhiman from AWS and Howard Peng from the US Department of State, we will take you on a journey that will hopefully change the way you think about the future of public sector services in the digital era. So let's begin. The way we've structured our presentation is as follows. I will first take you through a multitude of challenges that are faced by the public sector agencies as they try to modernize their systems and deliver on the promise of AI and generative AI. Now, in response to some of these challenges, I will describe the AWS Responsible AI Framework, which allows us to deliver AI in a manner that is fair, transparent, and secure. And then I will talk about some of the foundational Amazon AWS services for Gen AI. Next, Howard Peng from the US Department of State will join us, and he will tell you the story of how the US Department of State took that massive service catalog, that vast sea of information, and transformed that into an intelligent conversational interface that could answer complex questions in a matter of seconds. He will also discuss the various architectural decisions that they took. He'll also talk about some of the trials and tribulations they went through, and you'll see some great lessons learned from that presentation. And finally, Naresh Dhiman will join us on the stage, and he will pull back the curtain on this technology, show you how it works, describe the various architecture patterns that you can use, and then do a demo for you as well. Hopefully, this will be fun, lots of good lessons learned. Okay. A few weeks ago, while I was on a business trip, I lost my wallet. Now, my wallet had my credit cards, but most importantly, it had my driver's license. I was able to call the credit card agencies, and within 24 to 48 hours, I got the credit cards delivered to my hotel room. But it was going to take several weeks for me to get my replacement license. Luckily, I had my passport with me, so I was able to make it through the airport and return home that week. But it would have been really difficult if I didn't have that passport. I'm sure many of you have faced similar challenges when working with public sector services, whether it be trying to get a permit, a small business loan, working with Medicare, Medicaid, taxes, Social Security services, or any of the other services. But there are, in all fairness, really good reasons why public sector agencies cannot operate at the same rate and pace as commercial entities. There are several challenges. There are challenges around budgets and funding. There are challenges around skills, having the top technical skills to convert systems to more modernized state. They're dealing with a lot of legacy, lots of antiquated systems. And then, of course, there's regulatory compliance, security, privacy, as well as data sovereignty concerns that are hurdles to sometimes modernizing systems. Now, I work with public sector agencies across the globe, and there are additional common patterns that we have identified. And these are related to the complexity, the quality of data, as well as data governance. Most public sector agencies have their data in multiple silos, multiple islands of technology. And it is very difficult for these silos of technology sometimes to communicate and have a meaningful exchange of information across them. And then there are issues about how to access this data. Who should be authorized to access this data and when? There's lack of common collaboration platforms where data can be exchanged in a secure, private, and meaningful way. There are multiple tools being used within the same agency for mining of data, analyzing data, cleaning data, and sometimes governance is built within each one of these tools, and it's not consistent. And these are common challenges, like I said, that public sector agencies across the globe are facing. But these, again, are not the only ones, especially as you start thinking about AI. There are additional concerns around trustworthiness, toxicity, which is content moderation is sometimes required. And of course, there are issues around privacy as well as security. Now, in response to these challenges, we have at AWS developed what we call the Responsible AI Framework. And it is our approach to allow AI and generative AI services to be delivered in a manner that is fair, transparent, and secure. And there are 8 elements of this Responsible AI Framework, which include fairness, explainability, privacy and security, safety, controllability, veracity and robustness, governance, and transparency. And we have built our AI services in line with this framework. Now, let's talk about generative AI at AWS. I don't think that I need to spend too much time on this slide, but generative AI is a technology that creates content, it creates images, video, data, code, and it does it unlike traditional AI, which reasons with existing information. It takes a lot of patterns of information, millions of bits and bytes, and then it can provide original content. But it can lead to hallucination, it could lead to harmful data, et cetera, et cetera. Some of these problems are well known. But when we develop and deliver our generative AI services, we keep in mind that framework, the Responsible AI Framework, to develop and deploy these services. And these are the kind of services that Howard will talk about later in his case study. And with these services, we have, with this framework in mind, we have deployed many Gen AI services. The most foundational one of this is Amazon Bedrock. Now, this is a managed service which allows you to have access to multiple large language models using a simple API. It takes all the complexity away from you. But then it also provides you guardrails that handle the various issues with the data, with the privacy, with the transparency, with fairness, explainability that I discussed earlier. So for example, many of you may have heard an announcement yesterday where we introduced the automated reasoning checks for Amazon Bedrock guardrails. So they help with hallucination. There are additional guardrails in AWS that can reduce the amount of harmful data, that can reduce the hallucination, and then also there are custom metrics that you have that you can tweak based on your organization's responsible AI policies to help with hallucination, harmful data, and other and accuracy as well. Similarly, we have a service in SageMaker called SageMaker Clarify, which helps you identify, detect, and mitigate against biases. Within SageMaker, we have model monitors that will alert you if the model is providing information that may be not in line with what the expectations are. And then we have the human in the loop where using SageMaker ground truth, you can look at those anomalies and have a human intervention in there as well. So many of these services are available and have been developed with that responsible AI framework in mind. Now, with this introduction, after the introduction of some of the challenges and how AWS is addressing them with our generative AI services, especially with the responsible AI framework, I would like to invite to the stage from the US Department of State, Howard Peng, who will talk about the trials and tribulations they went through, as well as the architectural decisions they took and the lessons they learned as they changed and transformed that massive service catalog. Howard, welcome.
Really appreciate that. So, I'm not going to bore you guys with the bureaucracy of our mission statement, but I think it's well known that it's shared, right? And it's all about security, national security, cybersecurity, these things, right? These are universals. The mission itself with State Department is basically to prevent war, right? It's a very complex way that we engage with the rest of the world. And so there's a lot at stake here. Now, okay, so let me start with this. This started with a very, very painful customer story, right? As a technologist, I really do want to understand our business processes and also our customers. And in this case, it was pain and tears, 7 o'clock, 8 o'clock, 9 o'clock at night. And who am I talking about? I'm talking about my consular affairs colleagues, right? They're coming to me saying, we just have way too much regulations to go through to make informed choices on visa applicant decisions, right? Adjudications, so to speak. So look at this. I'm sure your eyes are glazing over right now. Not only is it 20 volumes of regulations, but it also changes. It's actually a living document, right? So how do you handle this? As a person, you can't memorize this. You can't always refer every single time, right? So you have to do something different. So this is really in the weeds, but it gives you a very good idea of what our folks need to look at, right? And this is for national security. Why are these people coming to the United States? What are they studying? What are they trading? What are they going to be focusing on, right? And as you can see, these are very distinct phrases. So with my consular affairs colleague, we did basic Python scripts. We'll do some phrase catching. We'll lift some things from PDF. We'll do all those things. That's great. However, the highlighted phrase there is computational fluid dynamics. Okay, great. But if you look at Wikipedia, there's so much language that revolves around that phrase. Nobody's going to say computational fluid dynamics. They're going to use all these other phrases, right? Same thing with quantum, same thing with nuclear. There's all these other bits that revolve around the subject matter. So we found out very quickly, okay, yeah, you can catch phrases, but this is more of a language problem. So how do we solve this, right? So while that was good, just to get us, thinking about these things, I brought in the experts, our data science folks in academia. This was during lockdown. So we were able to garner 200 interns over a 9-month period to actually build a corpus of data that focused on those very things. We actually built a language model. We didn't know it at the time, but that's actually what we were doing. So some bright minds looking at this from a problem-solving perspective for State Department. But think about that. 9 months, 200 people. That's a one-off. That's not repeatable. So what is that called? It's called Mechanical Turk, right? It's incredibly labor-intensive. Good, high quality, it's great. But it doesn't allow us to move fast, right? It doesn't allow us to pivot on new subject matters, new executive orders, new agency policies. It just, it's not going to work. And then you want to gamble on fine-tuning? Well, what do we do then? So this was our first proof of concept, and it actually came about between an honest conversation between Hyder Hamus, our account manager. He's like, hey, you need to start looking at this, Howard. This is a much, much faster way to not only ensure that you use the language model efficiently, but also putting on guardrails, right? Can you get it to answer what you want it to reference to only, right? Can you do that? And we're not talking about hallucinations or any of that. We're just talking about, I only want this, I want to explain, I want it cited from an authoritative source, right? Because we want to make informed decisions. We want to do a good job, not just, just go home early, right? Because, we can't just count on this to do it. We need to make well-informed choices based on our regulations for our agencies. So, this took about 6 weeks. To get from my team from 0 to this first iteration took about 6 weeks. They were not ready. They were not ready for this. I counted on Naresh and the AWS team to bring us into this environment, so it was quite a journey to shift from Mechanical Turk, the very manual ways of curation of our own data, to okay, can we use one of these language models? Can we pull it from Bedrock? Yes, it's FedRAMP ATO'd, okay. Can we make it work on our network? Can we get it to only look at our Foreign Affairs Manual, Foreign Affairs Handbook, right? That's what we want. We want some control here. We want some very well thought out controls. And so text is very small, but it's basically just kicking the tires, right? This is 6 weeks, very raw, very primitive, but it gave us a good idea, right? What we needed to focus on. And within maybe, I think this is like the 2-week mark, this is where things get really interesting. This is where oh, okay, not only are we making sure that it functions correctly, but at the bottom, there's that one line of all those numbers and codes. That's our regulation manual. So you want to talk about human in the loop, making good decisions? It's right there. They can refer to that and then lean on that, right? And so here it gets, the 4 or 5 week mark, we start to feel maturity. And the honest truth here is, it's a lot of trial and error. This is not user acceptance testing. You need to have your customer in the loop, right? Call your customer back, let's test it. Let's test it again. Make sure that they're very comfortable with this, right? And as Mickey mentioned with the governance issue, I think this is a key part. Not only is it explainable, is it transparent, right? And will it stop? Will it stop itself? Instead of giving an answer, just not giving an answer and saying, I don't know. No text found on this, right? And so this is kind of the point where we started getting there. It was quite exciting. So we learned quite a bit from this. We learned that not only could you use a modular platform for switching out language models, but as things change, you could actually change with it, right? So what I'm getting at is, what do we do with our data that we have, right? If our regulations change, well, we don't have to rebuild from scratch. We don't have to rebuild every single time, right? It's changing the engine, right? And having the same driver. That's essentially what this amounted to. So we took a step back from here. We were like, oh, wow, if we can do this, maybe this is a great jumping off point to getting our data governance together, getting our data cleaned up, clean house, right? And that's our preparation for the next steps in this. So to peel back more of the details, you know, the hands-on keyboard part, I'll introduce my colleague, Naresh. Thank you.
Thank you, Howard. Thank you for sharing your experience. We just heard about the challenges that our customer faced. And we heard about 10,000 pages and how issues they had in navigating through 10,000 pages. And so let's look at some of the architectural patterns that you can use to build generative AI application. And these might address some of the challenges that you might also face while building these generative AI applications. So let's step back and understand retrieval augmented generation, called RAG in short, which is a process of building a generative AI application for various use cases, such as a chatbot. So let me ask you a question. How many of you have already heard RAG before? We have pretty good audience. That's really good. Sorry, it might be some repetition for you, but let's give you a little brief on a RAG process. So RAG is a process of optimizing the outcome of a large language model so that it uses an authoritative data set, which is your knowledge base, outside of the training data set before generating a response. And in simple language, you bring your own documents, such as a PDF documents or Excel spreadsheets or maybe relational databases that get used along with the large language model for generating a response to the chatbot queries that you submit to the chatbot. So, and here is how it works. You have a prompt and a user query, which is a question submitted to the chatbot, is submitted to a RAG process. And prompt is nothing but a set of instructions provided to a large language model to generate an appropriate response. Now the RAG process will use the user query portion of that and search for a relevant information from your data sets. And it will return enhanced context information. And this enhanced context information is used along with prompt and the user query and submitted to a large language model, which is a text model in this scenario, which generates a text response. And the text response is a response to the question that you was submitted to the chatbot. It's pretty simple in that scenario, right? Our customer, Howard, used a RAG process to build their POC on AWS environment. And he eliminated the need to build their own AI/ML models, which simplified the operation of building a generative AI application, chatbot in the scenario for him. So you can build RAG using multiple ways. You can build your own RAG process too on AWS. And you do have an option of using a managed RAG experience as well, which is fully managed by AWS, right? So let's look at architectural patterns for building a generative AI chatbot using this RAG process. So in this architecture, we have a chatbot that is built using Amazon Bedrock knowledge bases. Amazon Bedrock knowledge bases provided you supports a fully managed RAG process. Just like in a RAG process I explained before, you can bring your documents, PDF and other documents to Amazon Bedrock knowledge bases, and it will use to generate a response to the user queries. So earlier today, Mickey highlighted some of the critical importance of responsible AI concerns, and also need to safeguard them in your generative AI application. Amazon Bedrock provides guardrail for you that you can use to build mechanism to safeguard your generative AI application from these responsible AI concerns. And these guardrails works hand in hand with Amazon Bedrock knowledge bases. You can use this guardrail to tailor for your specific use cases and responsible AI concerns that you want to handle or protect your generative AI applications. For chatbot application, like our customer built, you really want to make sure that you protect the user input from harmful content and the model responses from the toxic content as well. That's where Bedrock guardrail can help you to safeguard your generative AI applications. So here is how it works. You will bring your data sets that I have been talking about to Amazon Bedrock knowledge bases. You can upload your files to Amazon S3, or you can use relational databases, or you can configure web crawlers which can scrape the content from your web servers and use with the generative AI. You also have an option of using third-party data sources as well, which works really great with the Amazon Bedrock knowledge bases. Amazon Bedrock knowledge bases will ingest your content, and then it will use a chunking strategy to split those content into a chunks, and those chunks are converted into a vector representation using the large language embedding algorithm or model that you will configure with Amazon Bedrock. Then those vector representation is uploaded to your choice of vector database. And you have Amazon OpenSearch and Amazon Aurora, Postgres for your vector databases. You could also use the third-party vector databases as well. After that, your knowledge base is ready. Now it's the time for the chatbot to submit the user query. So you will be building a chatbot application. You can use a Streamlit to build a pretty good chatbot application. And you will submit a user query to the chatbot application, and it will use Amazon Bedrock knowledge bases, search for a relevant information, as I explained in the RAG process, which returns you enhanced context information that get used with the prompt that I have configured within this chatbot application, along with the user query, to send it to the large language model to generate a response. It really simplifies your architecture, right? So in summary, you get a couple of benefits of using a fully managed RAG process. One is it's a fully managed for you. It removes some of the heavy lifting from you in terms of building this complex ingesting pipeline. We'll talk about that more in the next architecture. And also maintaining an underlying infrastructure, right? The second, we understand your data sources are not static. They're going to change, right? You want to really take care of that changes as well. And you can do update the dynamic data with the help of Amazon Bedrock knowledge bases. You can do that with a few clicks, or you can use an API call to sync your data sources with vector database. Third, as I explained, you have a Bedrock guardrails as well that you can integrate with the Amazon Bedrock knowledge bases too. So next architecture is really when you want to build your own RAG experience. We understand for our public sector customers, there are compliance regions that you want to build because some of the technologies available with the Amazon Bedrock may not be FedRAMP approved for you to use, right? So you can still do that. You can use Amazon Bedrock, as Mickey explained before, Amazon Bedrock will provide you large language embedding model and text model that you can use in your own ingesting pipeline and a chatbot application and build a fully managed RAG experience, right? So here is how it works. First, you're going to be creating a ingesting application. This ingesting application is going to ingest your data from various data sources that you will have. As I explained, you can upload your data to S3, but in this case, the choice of this data sources is limited to what your application can talk to, right? So your ingesting pipeline will ingest the data. You will build your own chunking strategy to split your content into a chunks, and then those chunks will be converted into a vector representation. You will use one of the large language embedding model to do that, and then that vector representation will be uploaded to your choice of vector database, right? And choices are again limited to what your application can talk to, right? And then in the second part, which was similar to fully managed RAG experience, when the user submits a query to a chatbot application, it will use that user query and follow a similar process of converting the user query into a vector representation, which is very important, which you don't have to do in a fully managed RAG process. Then it will use that to perform a semantic search with your vector database to get enhanced context information. Then enhanced context information is used with the prompt and the user query, and it's sent to a large language model to generate a response. Similar process as I have been explaining with the RAG, but you do have some of the heavy lifting that you have to do for building this application. So next, let's look into a service catalog demo. We have built this service catalog demo to showcase you a practical application of a generative AI. And we have used a use case of improving your service delivery experience for your customers. And I have used this simple architecture to build this demo in my account, and it has a two-part. In the first part, you will use Amazon Management Console, and then you will have I have a fabricated data for this demo. I will upload that fabricated demo to S3 bucket. Then I will configure Amazon Bedrock knowledge bases. I'm configuring that with one of the large language model, which is Amazon Titan embedding G1 text model, which is pretty good, gives pretty good response. And then Amazon Bedrock knowledge bases will configure Amazon OpenSearch vector database for you, which is done by the Amazon Bedrock knowledge bases. And in the second part, I have implemented a tiny application. Its tiny application is called Service Catalog Chatbot. It's running on EC2 Windows. And your user will submit the user query to this Service Catalog Chatbot application. And it will use that information and securely connect to Amazon Bedrock knowledge bases. And then using that, it will leverage the knowledge base that we had configured, and it will get enhanced context information. Then the chatbot application will use that information and a prompt that I have configured within this application, and then it will again make a secure connection to a Amazon Bedrock that I have configured with a Anthropic Claude 3.5 Sonnet large language model, and it will use that to generate a text response that will send to this chatbot application, which will be sent to the user. Pretty simple architecture. So let's see that in action. So I'm on Amazon console, S3 console, and I'm going to be creating a S3 bucket. I'm going to choose some appropriate name, unique name for the S3 bucket. And then going to make sure that public access is blocked for this S3 bucket. And then going to make sure that encryption at rest is configured. And then I'm going to hit create bucket. Bucket is ready for me. I'm going to view the content of the bucket. And then I'm going to upload a sample data set that I have fabricated for this demo. This sample data set contains information related to the enrollment for health and benefits for your dental. And I have some financial information as well. But the key point is I have tiny bit information in this file. I have like 45 records describing about a little bit of a URL, a little bit of a description of the system, not much, but you will see the magic happening with this tiny bit information. File is uploaded, and it's ready for me to use. The next thing, I'm going to go to Amazon Bedrock. Then I'm going to look for Amazon Bedrock Knowledge Bases, which is a service embedded within Amazon Bedrock. And I'm going to hit Create Knowledge Bases. And I'm going to choose appropriate name for the knowledge base and the description as well, so that I remember that this knowledge base is for this service catalog. Then the next thing that you have to do is configure your data source. And Amazon S3 is configured by default. And this is what I was talking about, different data sources. And you have other options too. S3 is good enough for this demo. I'm going to give an appropriate name in the configuration in Amazon Bedrock for this. And then a URL for S3 bucket where this data set was uploaded to. And then I'm going to choose the chunking strategy that I talked about. You could have your custom as well, but I'm choosing default for this one, which works really well, very well. And then next, you can also choose KMS encryption as well for the in-transit data too. And the last thing, I'm choosing a large language embedding model. I'm using Titan in this scenario, and then choosing a vector database that integrates really well with it. I don't have to create this vector database. This will create for us, and it will upload all the my fabricated data, converted into chunks into a vector representation. I'm simply reviewing all the configuration before I hit create. Looks good. Takes a couple of seconds to create a knowledge base. Then it will start the knowledge base. It's done, and I'm going to go to my data source. And this is the one thing I talked about. You got to synchronize your data source, and you can do that as often as your data is changing so that your vector database is synchronized with your data set. It's done. It's ready for me to test. So I'm going to test this knowledge base before I use this with the chatbot application. I'm using the same large language embedding model, which was a Sonnet in the scenario. And I'm going to just ask a simple query, maybe list the benefits available to me. If I get some legit response, that means it is configured properly and it's ready to use. So I should be getting a response. First time it might take. I got a pretty good response. Looks pretty good. It means my knowledge base is ready to be used. So this you can all do using AWS console or use API. Next, I have the tiny application. It's running on EC2, and I have developed this application using a Python. And I have small scripts which is going to run this Streamlit application in Python. It will open that in a browser. The UI interface is built using a Streamlit, and it's really ready to asking for a question. So I'm going to ask a question that I just joined the organization or a company. Can you give me help that how should I get started with the benefits? And it's going to take a couple of seconds, and then it's going to give you a response back. Let's wait for that to happen. It's kind of saying, congratulations, you have health benefits, you have financial, you have insurance, and it's also giving a URL. It's giving a pretty good description to you. And I'm getting excited. I want to ask a question, how can I enroll, right? And let me ask that question. And then it's going to go and take a couple of seconds, and it's going to give you a response back. And in this scenario, it's going to give you a URL and the step-by-step instructions where you can go to the system and start enrolling for that, for those benefits, right? I'm getting excited. I want to really know what else I can do it. In this scenario, I'm asking that I'm going on a business trip. How can I get started, right? So I get information that you have to book a flight, you have to book a hotel. Here are the URL for those systems, and you can also view your trip details on this system, giving really pretty good information. Now, I really want to know if there is any app to manage my expenses, right? Those are the questions you usually ask, right? And gives you a URL to download your app, right? And then I'm concerned about expense policy, right? And I want to know what can I do when I'm on the business, what I can expense, what I cannot, right? It gives you a URL for the wiki, right? And then finally, I'm going to ask that, is there a corporate credit card that I can apply? And it's going to give you informations. Let's wait for it to give you a response. So it's giving you information that you can request a card, you can reconcile, you can get a training, you can do a lot of things. And I think the summary of that is, I had a tiny bit of information, and this chatbot returned that information to you in an interactive, conversational manner. Like you had a human on the other side, which was giving responses to you. And that is an experience we are talking about. Imagine if your user or customers has to look for this information, they might be searching for that enrollment URL in the emails, are going through your service catalog or service portfolio, navigating through all the systems, and finding the URL where they can start the work, right? But with the help of the chatbot, you can accomplish that in a few seconds, which can greatly improve the customer experience for your customers. So I also want to talk about a architecture that you can use for this chatbot to integrate with your own application. You could build APIs for the chatbots, and you can easily integrate that with your 2-tier or 3-tier application. You can call those APIs from web server, your web application, or backend application servers. I just wanted to show you this, that it's easy to integrate if you're building this chatbot outside of your existing application. We really covered a lot of ground today. First, Mickey highlighted some of the public sector use cases and important concerns of the generative responsible AI. Then our customer shared his experience of building this POC in his environment, and using a RAG, he was able to simplify his operation. Then I explored 2 architectures, one using a fully managed RAG and one without a fully managed. And we noticed fully managed RAG experience was able to remove some of the heavy lifting of building the complex pipeline and the underlying infrastructure. Then I showed you this demo, and the source code and instructions for this demo is available by a QR code on this website. The code is available just in case if you want to play in your own environment and get the feel out of it. And you could use a different data set to just run through it. We also have a blog that we published some time back that also documents some of the best practices, and I'm sharing that with the QR code as well. That was really a lot. Thank you for staying with us. We are now open for the questions.